Welcome again to Physics Galaxy. So today we are going to discuss some memory based questions from yesterday's net exam. Okay, so this is our first problem. So we have some charges placed at the corners of this cube, and the dimensions of the cube is a. Okay, and we have to find what is the total dipole moment for this discrete charge configuration. Okay, it's very easy. So what we write, P as we know is given by summation of Qi Ri. Okay, where Ri is the position vector of each Qi. Okay, and we have to sum it up. So I'll write P equals to, so for this charge I'll write minus Q times its position vector, it's A I cap, and for this charge I'll write minus Q times its position vector because it's in the y direction, so I'll write A J cap, and for this charge because it's lying on the z direction, so I'll write plus Q A K cap, and for this charge because this charge is at a point of 1 1 1, so I'll write plus Q times A I cap plus A J cap plus A K cap. So if we sum it up, we know this term will get cancelled out with this term with this term, so it will be Q A K cap plus Q A K cap, so we'll write 2 A Q K cap. So this is the dipole moment for this configuration. Okay, so one more problem that was asked in yesterday's net exam was that we have an infinite current carrying wire which is in this shape. Okay, and this is the direction of current, and we have to find what is the magnetic field at this center point B. Okay, so we know that the magnetic field due to this part, okay, at this point will be 0. Similarly, the magnetic field due to this part at this center point will be 0. Why? Because suppose if we have current carrying wire like this, okay, and this is a point which is along the direction of the current. Okay, so for this point, if we take a small element here, okay, dB will be equals to mu naught by 4 pi I dl cross r cap divided by r square, which is our Biot-Savart's law. Okay, so this is our dl, and for this point P, r cap will be in this direction, so we see that dl and r cap are in the same direction, so it will be 0. Okay, so only contribution will be coming from this semicircular ring, and for this semicircular ring we know it will be half of the full ring. Okay, and for full ring we know it's given by mu naught I by 2r. So the overall magnetic field at this center point will be mu naught I by 4r.